Welcome today. We understand polar graph, so let's start. This line imports two libraries, NumPy as NP for numerical operations and Matplotlib.pyplot as PLT for plotting graphs. Here we create an array R using NumPy's arrange function. This function generates values starting from 0 up to, but not including, 2, with a step size of 0.01. So, R will contain values like 0.00, 0.01, 0.02, 1.99. This line calculates the angle theta in radians for each value in R. Since the polar coordinates are defined in terms of angles, we multiply each value in R by 2 pi, which is approximately 6.2831, to convert the radial distances into angles. This line creates a subplot with a polar projection. The 1, 1, 1 means that we are creating a single subplot, one row, one column, one first subplot. The projection equals polar argument specifies that this subplot will be a polar plot. Here, we plot the data on the polar axis. The plot function takes theta, the angles, and r, the radial distances, to create the polar plot. This line sets the maximum radial limit of the plot to 2. This means that the radial axis will extend from 0 to 2. This line specifies the radial ticks, the marks on the radial axis, at the values 0.5, 1, 1.5, and 2. It customizes the number of ticks shown on the radial axis. This line sets the position of the radial labels. By default, the labels might overlap with the plotted line, so this line moves the labels to an angle of 22.5 degrees to avoid overlap. This line enables the grid on the polar plot, making it easier to read the values. This line sets the title of the plot to a line plot on a polar axis. The VA equals bottom argument aligns the title vertically at the bottom of the title text. Finally, this line displays the plot. It opens a window showing the polar plot we just created. In summary, this code generates a polar plot of a line where the radial distance varies from 0 to 2, with angles calculated based on the radial values. The plot is customized with specific radial ticks, labels, and a grid for better visualization. Now, run code and see graph. If any doubt, ask in comments.